Welcome back to the Economic Geology of Lunar and Asteroid Resources. Discussion today is on Phil Metzger's talk about operating on the moon. And take it away.
Okay. So on Monday, we had a great talk with Phil Metzger about operating on the moon. Basically, what we did is these are a bunch of challenges of operating on the moon, and then we went through them one by one and talked about them more. So I'm going to do kind of the same thing. And I know that there are some things that he kind of like glossed over, but we seemed like we really wanted to talk about. So we can spend as much time as we want on whatever we want, and we can skip whatever we want to skip. So the first challenge was lighting. So obviously the moon is tidally locked, and so the days and the nights are longer than on Earth. There's a very small tilt, but there is a tilt of the rotational axis, which means that the poles are in seasonal shadow cycles. This is a map of the South Pole, and all of the black spots are the PSRs. All of the white spots are the perpetually lighted regions, always lit regions.
Peaks of eternal light.
That's what it was. It
Peaks of eternal light, yes. It's very poetic.
It sounded beautiful, yeah.
Yes.
So the first question, which I know we've talked about a lot, but I still want to keep talking about, is how can we illuminate PSRs enough so that we can work inside of them? Discuss.
I like the mirrors idea. I'm a fan of your solar sail mirrored idea.
Yeah.
I like it.
So you have like a mirror up here that would reflect light, like the Mayans had in their temple.
Yes. I also still really like the idea of like lining the edges with solar panels and somehow transporting that energy down. I feel very silly that I didn't realize this earlier, but why can't you just have a wire that takes the energy down? Yeah, like I was like, oh, you'll just drive your vehicles up there and charge them, but why do that? Why not just have
a really long extension cord?
Yeah, like how we have power plants here that they pipe the power out. Like you don't go to the power plant to charge your car or to charge your home. It comes to you. We could do that.
Well, that's what's called a grid.
Yeah, a grid. We can make a grid.
A lot of infrastructure you have to build up first before you could actually do anything.
I mean, it's a power cable. Like
Yeah,
people build these infrastructure grids for things like, temporary oil extraction sites pretty easily on Earth. I don't see why you couldn't apply that technology to the moon, but with solar panels.
What if the wire gets stuck?
Bury it. That's what we do now. You have a wire, you dig a trench, you bury it, and then it's like safe.
Well, but
It won't be stuck on the moon.
what are you talking about, having the wire go directly to the rover, or
No, not directly to the rover, but
they'll have basically a charging station someplace?
have a charging station.
Like
how we
in the
charge
PSR,
cars.
like having a charging station
Yeah.
that's
So my worry with that is if you're heating PSR, it's very cold in there, and I just did a quick, didn't know this off the top of my head, but so water expands 1,600 times when it goes from a solid to a gas. A liquid to a gas, so it's about the same probably. But for a PSR, I'm wondering what would happen if you were to start heating the surface. Would it just immediately, would there be an explosion, rapid decompression?
Do we want to heat the whole surface, or do we just want to heat our instruments so that our instruments can work?
But your instrument's now touching the ground.
Yeah,
That's
but-
true.
If you have a giant crater and you're
But you're
little
also
rovers this
you're not
big.
going to be able to escape having some thermal transference from your mining equipment to the stuff you're mining.
I'm just worried about like an actual solar
like a big,
reflector coming down.
Maybe that's why they didn't have solar sails. They had those mirrors on
It's like a
stilts so you
mirror.
could focus it
Yeah.
and very specific.
I have the picture in here with Aaron, so we can come back to that.
Excellent. So prepared.
I'll move on.
But
Maybe I won't.
that is a real concern of liberating those volatiles by essentially the unintended consequences of your actions. And one of the things that you find working in permafrost regions is you tend to dig yourself trenches wherever you walk, because you're disrupting the surface, it's more likely to volatilize the frozen volatiles. And, you know, on the plus side, probably the volatiles are going to be a small percentage and disseminated. And so you won't have that much disruption, but you will have some disruption,
So you'll
I
wanna.
would think.
So will you wanna do, I know, in landscape architecture, you'll find that there's usually paved areas, like on campuses in particular, because if you don't pave areas, people will just walk on the grass in 1,000 different patterns. So would it be a good idea to pave areas almost immediately as one of your first steps so that
Yeah,
the volatile
like a designated-
transference, yeah.
This is the safe place to walk.
Yeah, well, and also I've observed that people don't walk just anywhere.
Yeah,
Um,
they'll make pleasure paths. You can see where people
You can,
wanna
there's,
go.
there are lines of least resistance that people follow, and you can just, you know, put the, it's smart to put the paths there.
Mhm.
When I went to graduate school, Brown had lots of green lawns. And since it was an Ivy League school, they spent a lot of money on groundskeeping. And so every summer they would put grass over all those places, all those beaten paths that people made. And then people would go and beat the paths again. And this was every year that would happen. And I thought, wow, you know,
Silly.
that's really an exercise in futility.
That's a new thing in landscape architecture. I have several friends that had to take this course at LSE, so I've heard a lot about it. Especially the cool parts, because fun facts. Everyone likes a fun fact. Is that new universities will now do that. They'll just wait for people to walk places, and then they'll look for the lines in the grass, and they'll put the path there.
Well, that would be a smart thing to do.
Mhm.
But I've seen the opposite, where for some reason they think that the next class will be more respectful of where they think the paths should be.
So they did a study, and if you tell people if there's trees, and especially if they're old trees, and you tell them that like not walking on the paths disrupts their roots and can kill the trees, most people will stay on the paths, like a high majority. But if it's just grass, that doesn't work.
Okay, well,
Thanks, landscape.
it does work in Cambridge, where they have lots and lots of signs and very lush grass.
I walked on the grass.
I'm shocked.
Which Cambridge?
Shocked. Cambridge, England.
Oh,
never mind.
Continuing.
Continuing, so.
So more about lighting. The moon has a very dark surface, so it's hard to see on the moon. There is earth shine from the earth onto the moon that can help illuminate shadows, but it's not helpful for the PSRs because the earth is below the horizon there. Light reflected off of the terrain into the PSRs can be helpful, but I don't know, it'd still be better to have more light. There's non-Lambertian reflection due to the fairy castle arrangement of grains. So this one is Lambertian and this one is not.
So I've looked up what fairy castles are before, but I'm still not 1,000% comfortable with it. Besides, it's some kind of structure built from electrostatic grain
My
interactions.
understanding is that it's kind of like cotton candy,
Oh, okay.
where it's like,
Fairy floss.
yeah, like there's air inside of it and it's like little stringy strings, but it's
Okay.
like if you pushed it down, it would compress, but
Right.
it is like a
It's
surface.
stable.
Is that right, Dan?
So I kind of study that.
Oh, cool.
Okay.
So it's very, on Earth, we try to make these substances. So basically, we see these very porous structures. So porous is like the bulk density of the material. So you have basically grains perched on top of each other on Earth would be very delicate and not stable structures. You can imagine on the moon, or imagine an asteroid where the gravity is 1,000 times less, 1,000,000 times less. Grains can sit in these very unstable structures, and plus electrostatics can actually make things literally repel off each other. Actually see,
Yeah.
there's the lunar horizon glow where we actually see things getting projectilely launched, grains getting launched just from this equipotential lines. And yeah, so it's really just imagine think like the cotton candy is a good analogy. I like a dust ball. If you ever look at a dust ball under a microscope, it's
Like a dust bunny?
yeah, it's almost completely empty space with you can actually get links of dust literally linked like this. And you think about it, they're all solid particles. How are they doing that? It's the electromagnetic field. But yeah, on the moon and asteroids, you basically have these structures that are almost tendrily, and they really stretch out away. And we've tried to bring them to the Earth. The second you scoop them up, they collapse.
Yeah.
We tried to make them on the Earth. That's very difficult. That's currently kind of the things that we're trying to do in the lab. We've tried to do it without electrostatics. We're now trying to do it with electrostatics and plasmas, and that's kind of the next step. But yeah, we're talking about porosities significantly below what you would see in normal Earth soil.
Have they been able to replicate it like on ISS or something?
Ooh, good question.
Dan, do you know about that?
No, I don't know if they have or not.
So our goal is to put something up in a low Earth trajectory
Okay.
and have it come back down and see if we can. But the problem is you need to make a machine that can do it,
Yeah.
and you don't know if the machine can actually do it until it's in that environment because it can't do it here.
Could you launch a CubeSat?
CubeSat is one of the things we want to do as well.
Josh has done that.
Yeah.
With which I forgot the name of the experiment, but basically it creates the structure, just as it's like in free fall, but then it easily collapses.
So I know Addie has done some where you make the experiment happen while it's just falling in a drop.
The
chamber.
parabolic flights.
Drop out.
Well, yeah, just doing it in her own lab,
Oh,
dropping
oh,
it
there's a
and
drop
just a
down.
high-speed camera, and it gets it. But you're only getting 2 seconds of.
Yeah.
I like
Right.
the idea of putting it on the ISS. I think you should do that. Addie's put something on the ISS before. You can.
But yeah, Addie's on my committee, so
Yeah.
hopefully we can get something cool. But yeah, so it's basically a really empty structure of grains kind of balanced in a way that we wouldn't have on Earth. And when we first see these things, it messes with the spectra because spectra
Yeah.
has a porosity
Yeah.
part to it. So
Yeah, so also UV light is more damaging in space. It's bad for biology, obviously, and it can break down materials such as plastics and fabrics. So a question would be, what can be used to protect people and equipment from UV besides like giant sunglasses and sunscreen?
I mean, you can carry around basically an umbrella or something. That'll work. If you've ever seen like people that are very pale carrying an umbrella around with blankets, you can do that.
just going to PSR.
Yeah.
Yeah.
That
is-
Strap on down.
But
Well, I think the major issue is what kind of coatings you have on your transparent faceplate that are
Yeah.
opaque, that can be opaque or reflective to UV.
Well, you probably want to have a polarizer at the very least.
And I believe the astronauts had a
gold.
gold cover.
Have we done any studies on that? Has that been? Did they break down in the 5 days they were there, or like with that
Well,
vest? If you were there, for
Gold
a
doesn't
month,
break down too easily.
even
However, it abrades.
UV is bad for peptide bonds and hydrogen bonds.
Yeah.
So that's why it's really bad. It's bad for people because it ruins your DNA. It'll easily break it, and then every time you need to repair DNA, you have a higher chance of a mutation going poorly or just it being fixed wonky, and then your DNA doesn't get read. It's bad for plastics because plastics also rely on these dehydration and hydrogen interactions.
And of course, what do you use the plastics for on the moon?
I mean, yeah, a lot of things. They're light.
Seals,
Yeah.
gaskets,
Important thing.
things to keep the atmosphere in and the vacuum out.
Anything you don't want thermally expanding or contracting.
Yeah.
Talk about that in a minute.
Excellent.
Okay. This is a really cool. I'll tell you about it in a second. Okay, so radiation, we know what radiation is. Yes, so basically our electronics have to be designed to work in heavy radiation environments, and you also don't want your crew to be too far from any radiation shelters. So this is really cool, because I know someone had asked what was the frequency of what?
Oh, no, I asked.
Yeah.
I wanna
What was
know.
the frequency of like really terrible solar flares? So
Yeah.
I found this on the internet. So like this line is annual exposure. This is annual exposure for a radiation worker. This is short-term radiation sickness, and this would be a fatal one. And so all of these lines are solar flares, and then these lines are the Apollo missions. So,
And you notice that the scale is logarithmic. So it gets really big really fast.
so
I'm
during,
sorry. Could you say which are the Apollo missions, which are the
these are
flares?
the blues are the Apollo missions,
Oh,
and these are the flares.
Okay.
So you can see that the only one of them during all of the Apollo time was actually fatal.
16 and 17.
And like, thank goodness there wasn't a mission at that time, because he said they would have just died.
Yeah.
But yeah, so most of them were in this annual exposure to a radiation worker level. A couple of them did go to short-term radiation sickness, but you're not gonna die. So this made me feel a lot better about
Going to the moon.
not even, but just like, because when Phil said that there was just like, they're gonna die, maybe, that made me feel a little iffy.
Well, I think
As
the
one
plan,
would.
I think the current plan for the Martian astronauts is still that they will probably all suffer like extreme cancer due to the radiation load from the trip there and back. So,
Right.
Fun.
But I mean, that's, the price of science, right?
Yeah.
The x-axis is only 4 years though, so that means that once every 4 years you have a pretty good chance of.
That was my
Getting
thing,
COVID.
is that I wish that they had continued this part at least onward.
Well,
Well,
so
we'd like to see at least
is
one
the-
whole solar cycle. Yeah.
is the 1972 one? I don't know if anyone knows. Is the one that slammed into Quebec and took out their entire power grid?
Ooh, good question. I have the solar storm of 1859.
That's the crazy one. You were to
Yeah.
put 2 sticks in the ground and create like metal sticks and actually get a current to ride a light bulb. That's how
Yeah, so-
that was the Carrington event.
It was
Something
the
was-
one that
1850.
fried all the early electronics. Like they laid a
People got
very
zapped on the
early-
train across the transatlantic.
Yeah, it melted it. They had
yeah.
to lay another one,
Yeah.
which is
So,
hilarious.
yeah, they had the transatlantic cables, and the operation workers got electrocuted by it. Not killed, but zapped.
I hope
And
not,
then
'cause
people
you're
were able to
smiling
take
right
like
Right,
two
right.
pieces of metal and just put them in the ground and meter apart, and it was enough
That's
electric potential to power a light bulb and
a
stuff.
meter across?
Yeah, that's all they needed
Amazing.
was a meter.
The 1972 solar flare knocked out long distance phone communication across some states, including Illinois. And AT&T redesigned its power system for transatlantic cables again in 1972 because of that event. So
So
There
that
you
one
go.
sounds like it stood out.
yeah, that's.
Do you have a list
particular-
on there of like what were some big ones or?
Yeah, how many big
Question.
ones have been since?
Hold on, guys.
'Cause I-
Why were you not ready for this? Come on.
Is the plan for the Martian astronauts that they've got like 2 weeks once they get this fatal radiation, or like how shielded are they gonna
I
be?
think once you go to Mars, you're just on Mars.
Yeah, but like how long does it take to kill you?
If you got
Well,
hit
he
with that,
said
the
2
fatal
weeks.
one is 2 weeks.
Yeah.
Well,
It
the
was
So
sun
you're not
really
making-
slow.
So just don't be there during a fatal one.
source of radiation.
Thanks,
Alright,
Kenny.
so-
You're welcome.
So no one's really compiled the pre-1989 solar flares, but 1989 solar flare was the solar flare that made power
That was
outages in
89.
Quebec.
Dang.
2010 there were 4 solar coronal mass ejections emanating from the side facing us, but none of them hit us, but we got significant aurora. 2012 there was a very big EMP that almost missed Earth. I remember that because people were like 2012.
Yeah, everyone's
It's
gonna die in
happening.
2012.
Yeah,
Almost missed or almost hit.
almost hit, it did miss. 2012 again in August, there was a minor coronal mass ejection that did contact, and we had auroras at night on the 3rd of September. And then we've been in solar minima pretty much since. We've had a particularly low solar
Yeah.
cycle, so
The sun's been lame lately.
yeah.
So we could aim for solar minima.
I think that
Just
would be a
assume
bad
everything
idea.
will be okay.
And you think that in another decade, right? Solar cycles, what, 10 years, 12 years?
11
years.
11 years.
You're so close.
Yeah, well, no. The average of those two.
Solar cycle,
So I mean, if once we get to the moon, if we're there for 11 years, obviously not continually, but 11 years, then you take 11 years of a little calm down and get your
Like,
technology better. Maybe you'll be good for the next
Inside
one.
time, Yeah.
Yeah.
Yeah. go.
Oh, we are at the very beginning of solar cycle 25. The
Mhm.
last solar cycle ended in late 2019.
Ooh.
So we are currently like right at the lowest minimum point.
We're gonna start ramping up soon.
Yeah.
So
By the
bad
end of
time
this
to
year,
start
they
the
say.
space program. Up again.
Wait another 11.
No, you want to like 5.5 years because another 11 years will be at the ramp up stage again.
Yep, no, yep, that's math.
You want to just,
You're right.
Five and a half.
or probably 8 years. You want to be in the lower.
I did have a question. How much should we care about these? We kind of just talked about it.
Yeah, we did.
Okay. Plasma and charging. The solar wind is plasma. It's constantly blowing, but it's currently very low energy, so whatever. Obviously not whatever. Solar wind will interact with Earth's magnetic field as the moon passes, and the moon passes through the magnetotail.
Oh, cool.
And we did talk about this another time where we talked about implantation from solar wind could be a source of volatiles, but he did say that that would be a very low concentration. So
But I think it would be an important source of nitrogen. I haven't
Yeah, okay.
seen a very good plan for getting enough nitrogen to the moon because every time you want to make a new thing that's alive, you need nitrogen. You need a good chunk of nitrogen, not only to form them, but also to feed them. So, like, if you want to raise livestock or eventually children on the moon, you need a reliable source of nitrogen.
same thing.
Well, I mean, we're probably gonna raise chickens before we raise a lot of children.
Hopefully, yes.
So, do we know what percentage that the magnetic bow shock and all that incorporates from the moon's orbit? Because that could be a good time,
Yeah.
just as it enters and then have
Um,
astronauts leave on the way out. I don't know if that's to
I mean, I
scale.
personally do not know.
Because if that's to scale, then it's what, like 40%?
I don't think it would be to scale.
Well, obviously the moon and Earth aren't.
So would you want to plan your excursions like when the moon is in
It's
the
gonna be
magnetotail?
it's gonna be on its way into the.
Yeah,
I would assume
because it looks like
on the
you
edge,
know-
you're probably getting things getting directed towards. You probably don't want to be there, but as you
Yeah.
get into the.
Yeah, when you're not in the red part, that's
Yeah.
probably the best time to be outside on the moon.
We're
Yeah, blue to
protected
blue.
for a quarter of the moon's orbit.
Okay, so a quarter. So
That's pretty good.
25% of that 5.5 years, that's dangerous.
So about one.
I mean, and lunar goes around in what, 29?
29 days.
Days?
So
Something.
1 week.
Yeah, you get a
basically.
week. You can get a week there,
That's
which
pretty
is
good. So you could
good
do
starting time.
like long-term excursions from your base like during that week.
And how long does it take to get there? 3 days? Apollo
One
said.
Texas.
One Texas.
All the cool
The
stuff.
moon is more than
No, no, no.
Texas.
It's more like
A little bit.
Texas.
A little bit.
Expert. All the cool stuff on the moon is at least one Texas away from the
Oh yeah, the
poles.
moon is 3 Texas.
Yeah,
Because my worry with that is if it takes you 3 days to get there,
yeah. you
3
might
days to
have a
get
day.
back.
Right.
Yeah,
You have
That's-
1 day.
that's not a good-
One
Yeah.
day.
Yeah.
but that's also probably still your best time to be out, even if
out
you
on
know,
the surface.
even if you only get like, okay, let's say it takes you 3 days to get there, 3 days to analyze, and 3 days to get back. You still probably want to plan to be in this this shield as much as possible.
Yeah.
But eventually we will have separate moon bases, and that's just a
Yeah.
3-day trip to get there, and then you stay there.
Well, you just build a
until-
tunnel.
But I mean, like if
You don't need to be on the surface.
if you want to be on the surface, you
Why?
want to get some fresh air. I don't know. Like that could be
You wanna-
travel time.
Some lovely
Yeah.
fresh vacuum.
Some fresh air. It's a not tenuous
Alright,
atmosphere.
you heard it.
It's a sphere.
You heard it from this class first. We predict that there will be hard transport cycles that are
And then, of course, if you get to the PSR again,
Yeah.
you're not really getting hit.
Yeah, who really cares?
You're getting hit with tangential radiation.
What? Well, let's talk about
You
that.
didn't pay me to say that.
So there is charging when UV light knocks electrons off soil grains. The day side is going to be positively charged, and the night side is going to be negatively charged. There could be sputtering into the PSRs from this, but that was not well known. And there was a diagram, but it was basically just sputtering.
we do that in our lab. That's one of Katie's jobs.
Yeah. So we need to design our hardware to interact and manage with, certain plasma, but this is something that he made it a point to say we don't know a lot about. So I just thought that was, kind of iffy.
It is.
Okay, thermal stuff. Primary thermal drivers are sunlight and background radiation of space. There are extreme temperature swings on the moon because there is a lack of atmosphere. So on the equator, you get about a 300-degree temperature swing. This is one day. At the poles, it's better. You can get only about a 20-degree temperature swing. In the PSRs, it is just always cold. Very, very cold. Colder than Pluto cold.
Wow.
Assuming Pluto doesn't have craters the same way.
Interesting. I'll think about that. So your hardware has to manage these temperature swings. Like we said, your materials will become brittle or hard, or there will be thermal expansion, which is why you would use plastic, but then we just said plastic is bad.
Well, there are plastics that degrade less in UV radiation, so they're a little more brittle though, which is a problem, especially
For a
for
hammer.
super cold. Yeah.
And also just managing, you have to keep everything warm, so just making stuff warm takes energy, and we already said that we can't really use nuclear because everyone will get mad at you.
Yeah.
Exactly, that's my plan. So a question is, how do we protect or build the hardware so that it can, assuming that there's no other challenges to face, just thinking about thermal stuff, how do we?
Line it in something with a low thermal inertia that's not UV degradable, like the regolith.
Just cover everything in regular.
Yeah,
Can we
Bury
even
it all underground.
can we even really test these? Like, I'm wondering, like, you have a washer or something. How do you even test if that can go down to 20 Kelvin and last there for a minimum a week when they're there, if not returning months, years?
Well, I mean, there are dedicated vacuum chambers for that.
So it can get to 20 Kelvin and,
We can get to 11
Exosphere.
Kelvin. Oh, cool.
but I mean, also you need like a room. I mean, you can't just like put it in a little vacuum chamber. You need to be able to see what it's getting hit with
NASA
or
has
something.
a room that's like.
I've seen that massive room.
Yeah. So
But also, this is out of my expertise, but you know, how much is the difference between what's the 10 to the negative 18 tour or something? 10 to the negative 12 tour, sorry.
yeah, it was like not 18.
Not 18, that's,
Not
that's,
18.
that's
That's
extragalactic.
deep interstellar space.
10 to the negative 12 tour, I mean, how does that compare to 10 to the negative 8 tour? That's what I feel like most vacuum chambers.
Yeah, so our vacuum chamber now gets down to like 10 to the negative 11 regularly.
Oh, okay.
It is something that you do need a somewhat smaller vacuum chamber to achieve. That being said, I think that it's not impossible at this point with our technology if NASA really wanted it to build a, maybe not room sized one, but something large enough that you could park stuff in and you could have like holes you manipulated where you'd like poke it. That's very technologically feasible. I don't know if that currently exists, but I believe with several $1 million you could make it exist.
Seems like something the Space Force would want to invest in.
It does seem like something Space Force would want to invest in.
Now, why do you want to go down to minus 12?
That was the exosphere of the moon.
Yeah, but why would you want to do that?
For just testing how a washer or something would work under that.
Relative to the exosphere. So you'd want to know reaction rates with the.
Well, so my first question, because I don't know a lot about
Because you
this,
want to do
but
heating cycles on
Yeah.
it, right? And you want to see what's the heating cycle just from incident radiation, not from like thermal transfer
Well, you're not going to get much thermal transfer even
at 10 to the 8. Yeah.
at 10 to the 8.
You're not
so you
wrong.
think like a lower vacuum is probably still a good proxy?
It depends on what you're doing. If you're interested in looking at the exact chemistry, because you cross some important chemical boundaries relative to oxygen fugacity between the minus 8 and minus 12.
It's
But-
volatilization too. Like we have a very good vacuum chamber because we focus on volatile chemistry.
But probably for almost all applications, except very, very constrained ones. For instance, you're in very reducing conditions at minus 12 and not so reducing conditions at minus 8. So if you convert oxides to pure metals, for instance, iron oxides to pure metals, even that's no big deal. You know that because your oxygen fugacity is higher, you're making oxides rather than your metals. So I don't know if it's all that necessary to crank out the last few molecules of
I don't think it
of
is,
stuff.
but someone could. I would be willing to be proved wrong.
Well, I'm always willing to be proven wrong
Well, okay,
because I'm wrong.
Maybe,
You shouldn't
more
be upset
accurately,
at that.
I don't have a strong opinion.
Yeah,
But I don't do vacuum chamber stuff. as
Yeah,
as
well-
everyone else.
What pressure unit are we talking about?
Tor.
I'm not
so -12, 10 to the -12 torr. So
Oh,
you can
okay.
literally go and name all the molecules that are floating around in your chamber.
Yeah,
You're
so
Bob, you're Greg,
Yeah.
you're Susan.
we can like one of the things we can do with our current vacuum chamber is when you irradiate it, you create daughter molecules, which are like novel new recombinations of molecules. And like if we only have one unique daughter molecule in the chamber, we can see it.
One.
Yeah.
Give your molecule a long name then.
Yeah, it's our special it's our special molecule.
Yes. Well,
Yeah.
That is sweet though.
I was just wondering, if you really wanted to reproduce all the conditions at once, you'd have to get something down to -20.
Yeah.
You'd have to pull out literally all of the air,
Uh-huh.
and then you'd have to hit it with UV, and then you'd have to be able to actually measure it. 'Cause
Yeah.
this object's never coming back.
Right.
So
Don't you have to be careful when you're working with extreme temperatures in vacuum in the lab?
How so?
That's
I
the
mean,
thing.
yes,
Definitely.
but
You don't want to get to too high temperatures in the vacuum chamber.
well, right.
Or
If
else
I
the heat gets trapped.
Some bad stuff's gonna
And
happen.
bad stuff happens.
yeah, so
Yes.
one of the things we're doing is like we're trying to build a second chamber for space weathering right now, and that will be like a temperature cycling chamber, but we can't cycle quickly. So if you were like, I want to take it from 150 Kelvin to not 5, we can't get to 5, to 18 Kelvin in like 10 minutes, no. But you could do it over the course of several hours.
So, temperature swings and lack thereof in the PSRs, is that a pro or a con for going to PSRs?
Great question. I think it's probably a pro, but I'm also a fan of the bury everything regolith plan, which would, not really.
And another thing is, in cryogenic temperatures, a lot of things, you won't have like things like necessarily becoming brittle. Well, actually, you do have that with certain
things
materials.
do get,
But also, like, just in general, things can go wrong with the hardware. Things
Yeah.
can just
Yeah.
completely change.
well, yeah, you're slowing all the
You know,
chemical
the
reactions
materials
down.
expand,
and-
contract.
So for some things, it's a bonus because you're reducing the electron noise, and for some things, it's a hindrance. Does doping work the same? With like
In
with a
Diodes?
superconductor. Oh.
at extreme cold
really
temperatures?
cold, somebody asked me.
Should.
It should?
Yeah.
Okay.
I feel like they should.
Something that works really well at really cold temperatures is Delrin. That's a material that I used in the vacuum chamber.
Okay.
And it was able to like handle extremely cold temperatures. And I had like a frost layer around the metal block. And the Delrin could handle it. It doesn't become brittle or anything.
So it's just a question of choosing the right material.
What would you say is really cold temperatures in this case? For like,
18K.
Hmm.
20K.
Superconductors work really well. I think that's
Yeah.
the positive for that. I mean, you can bring up things that don't work at all on Earth, and then you just lay them out on the moon, and
If you have a CCD telescope, it would work extremely
Yeah.
well.
I mean, you'd have electrons flowing effortlessly, basically.
Yeah.
You'd have to manufacture and then bring those to the moon, most likely. But
Yeah, that's okay. What is it?
Oh, this is temperature at the poles and inside of the craters it's cold. That was the point of that.
it is very cold.
Okay. So he showed us that map of thermal inertia. of the regolith, and he told us that as you go forward, soil becomes fluffier and less compacted. So I went to that guy, it's highly debated. So I went to that guy's paper and looked at the rest of the plots, and these are the same thing except for it's on the, what does he call this, sphere projection? It's on a sphere.
Oh, I know what you're talking
Stereo
about.
graph?
Yeah.
Is that the word?
Yeah, stereo sounds right.
Sure,
It's-
whatever. So the scale bar is, this is thermal inertia decreases as you get darker. So I know on the plot that he did show us, it did look like towards the poles, the thermal inertia was decreased, but I don't really see it here.
It's a stereo projection, you were right.
So my question to you is, do you believe the Hayne guy's conclusion? Or, I don't know, because I don't know enough about this to even talk about it, but I just thought these maps look cool.
That's one valid thing. I mean, it's either a chemical thing or it's a physiological is not the right word. Physical
So
property thing.
I-
Yeah, I know, right?
once again, it's kind of out of my expertise, but I would think if you had more thermal inertia, thermal inertia goes which way? If
The more thermal inertia you have, the less likely things are to change temperature.
Okay, so I would say the things with the low thermal inertia would crack and shatter more easily, right?
Because they're changing faster.
Yeah, they become more brittle and disintegrate. And then you'd have more of this fine material, and then that fine material would, assuming it doesn't easily migrate, if it stayed put, it would make more of that Barricastle structure, which would be a fluffier material. So I
One
would,
thing to remember though, is that thermal inertia is not a fixed number per each material. So thermal inertia varies with temperature.
Interesting.
Okay, and the poles are
And
colder.
so it has a tendency to get lower with lower temperatures.
What measurements did Hayne use to make these plots? Like, what do you measure?
I read it and I forgot it.
Probably like collapsed temperature maps, like if you can check the temperature of things and then you can see like, okay, this sliver has just entered the day side, how long does it take to warm up? And like if it warms up quickly, then it has low thermal inertia. If it warms up slowly, it has high thermal inertia. Is that right? I'm just like,
and then you get it on the other way.
okay.
Cool
What's
down
the
as
sand
well.
analogy at the beach?
Yeah.
Yeah.
Sand in the concrete.
Yeah, sand, something heats up quickly, it retains its heat for longer,
Yeah.
and it loses heat quickly as well.
Yeah, okay, so is that sand high or
Sand
low
is
thermal
high.
inertia?
Has.
I think water is a better way to think of it, because the water doesn't change as much, so
When I was
that would
making this
have.
last night, it took forever to think about this.
So once again, I don't know
low
how it
thermal
works,
inertia
but
means that it changes temperature easily. That makes sense to
Yes.
me, and I'm picking
It's
that as
resistance to
distinct.
change.
Yeah.
So if you have low.
so then it would change slowly. So water would have a high thermal inertia, because it takes a lot to cool it, warm it up, and a lot
It
to
takes a
cool it
long
down.
time to do it,
Well,
yeah.
so, but in terms of mineralogy, water is actually not particularly skewed to one side or the other in relation to thermal inertia. It's better to talk about it as like boulders versus fine particles.
Yes,
So
sand and
rocks are
concrete.
high, dirt is low.
So things with high thermal inertia are things that take a while to change their temperature.
No.
They rapidly change it.
They rapidly change their temperature.
It's easier to change the temperature of a large bulk object where things are interacting and touching than things that are separated by empty space. So like sand has air pockets, and like air is the best insulator, except for vacuum, which is an even better insulator.
Wait, so sand has a low thermal inertia?
Yeah, the more
Yes.
particulate, the lower the thermal inertia.
So I was thinking,
Okay,
I was
and-
thinking like the sand would have more surface area, so it would make it easier.
Yeah, it does have more surface area, but it's not 100% in contact with its neighbor particle like something in a boulder is. So you
It's
don't
not
have
conducting
a,
as well.
you don't have as good of heat
I guess we're also not looking into the depths of the boulder either. We're
Yeah.
only looking at its,
Yeah.
The skin.
okay. Skin
So
depth.
Hayne is saying that the poles are colder and therefore have lower thermal inertia, and so the grains are finer and so
Yeah.
they're fluffier.
except that he adjusted for the fact that thermal inertia drops with temperature for any mineral.
So that's, okay.
If the average temperature is colder, you should expect
Right.
that the thermal inertia would be lower for any particular mineral if you hold every at any compaction.
Yeah, because things don't like being 20K.
Well,
It's only 20K in PSI.
I think they're just fine with being 20K. It's just that's the way stuff is put together.
Okay, fair enough. They're not. I should stop anthropomorphizing everything.
Yes.
Um,
Well, that's okay.
So Hayne also showed that these are 4 different craters with different years. This is the young ages. This is young, kind of older, and oldest. And thermal inertia, again, the darker is lower thermal inertia. So there's high thermal inertia, less. So he also
So
said,
rock.
well, he also just said like age, but we also learned, remember, that the young craters have the fluffy stuff around the rim. So that makes sense. And I didn't mean to put that question there. That was just for me when I was thinking, and I meant to take it out. So we're just gonna keep going. Gravity. So gravity, obviously, it's lower. We talked about how the dynamic forces are more dominant on the moon than they are on Earth. So like weight and traction would be reduced, but inertia and tipping torque would not. All the forces you feel in a moving reference frame are not reduced. So that would obviously cause some problems when you have a boom swinging,
So I don't get, why can't we just
like bolted in the ground,
no, just like pick up some rocks and put them on so it's
make it heavier.
Yeah, make it heavier.
How much heavier would you have to make it?
6 times heavier.
What's
Yes,
picking
yes.
up the rocks?
What?
What's picking up the rocks? Just the astronaut?
Yeah, me. I'm
Sounds-
picking up some
sounds
rocks and I'm
intensive.
weighing my stuff down.
Sounds like a
But
lot.
I don't
Why can't
see
we just
how
bolt it
that-
in the ground?
How are you gonna
Well-
bolt it into the 20-meter thick loose regolith?
True.
I mean, you could put something under there that tries to open, but yeah, it would be difficult. I picture it kind of like trying to go into sand and gravel.
Yeah,
It's not gonna be fun.
except worse. Is lunar regolith non-Newtonian? Okay.
I don't know.
Also, what is an auger? I meant to ask that. And
It's a drill. The hand drill.
It's like a
like the thing you get an umbrella into the beach.
yeah,
Yeah.
exactly.
Okay.
So yeah, those don't work
They-
in low
I only
gravity.
get the cheap ones you have to stab into the sand.
That
I
never
think
works.
the drills don't work either.
But in low gravity, augers don't work. Walking isn't that great. Flow
Skipping's
dynamics.
really good though. I've
Yes.
done the 1/6 gravity belt
Bunny
thing.
hopping.
Bunny hopping's trash. Disagree.
What?
Bunny hopping is not as good as skipping because you gotta like make sure both your feet hit at the same time or you like skew. If you're skipping, you're already planning on having only one foot hit. But this,
Well, but
they had
if you're in a kind of rigid suit,
uh-huh.
which is why these guys went to bunny hopping.
Well, there was actually 3 gates that astronauts fell into, and it depended on just kind of how they like ambled. But bunny hopping was like one of the 3. Some
Yeah,
people did
but-
prefer to skip, and it's just kind of a personal thing, which I
Yes.
appreciate.
Well, it depends on how coordinated these guys are.
Mostly airplanes.
At any rate,
Yeah, I had an Apollo astronaut tell me that he skipped on the moon.
What about trotting?
I don't really think you can trot unless you have 4 legs, but I'm not sure. I mean,
What about just like doing the work? Is that feasible? What other processes can we think of that could be re-engineered, like skipping?
I mean, jetpacks work on the moon really well.
Wouldn't that blow up?
I was gonna say that would probably
And that's
blow a
true.
lot of regolith.
Well, you can maglev it apparently, because maglev works great on the moon.
Yeah, I was thinking about that a lot.
well,
Has anyone?
go ahead.
No, I'm gonna say
Go
something
ahead.
dumb. It's okay.
Go
I'll say
ahead.
my dumb thing after you.
No, after you.
Has anyone read the Uglies book series? It's like a young adult novel.
Wait, uglies and then pretties?
Yeah.
Oh my god.
So-
Yeah, I have.
In this book series, they have it's a sci-fi book. They have like iron buried in grid patterns over their cities, and the teenagers get around by hoverboards, which are
Oh,
skateboards
Oh, that's cool.
that
Actual hoverboards.
yeah interact with the magnetism. And so when he was like, "Oh yeah, maglev works really well on the moon," I was like, "Oh sweet, like lunar hoverboards. That's how everyone's gonna get around."
Any other processes that we're
No, Dan said he'd say it's real.
Oh
thing
yeah,
now.
say the real thing.
He doesn't know what to think right
How
now.
do you know what I was gonna say?
You said you were gonna say something. It has to be a better scientific way than me making an observation about a several years old.
He was
But
gonna
No,
touch
I
on
think
the
that's a
ugliest
fine
series.
observation. The fundamental problem here is that a lot of particularly our excavation machinery, depends upon mass to make it work. And drilling quite often depends on mass. You ever been to a big drilling rig, anybody?
I've seen one.
You've seen
Next
one?
to one.
You notice that what they do is that they have a big tensioner on this thing where they take piles of iron and dump it on the tensioner so that it produces downward force. And literally they'll put 100 tons of iron on this. And that's not going to work as well on the moon, even if you spend a lot of time picking up rocks. So you need to be creative, and using gravity as a crutch is something we need to get used to not doing.
How would more mundane things, like if we're living on the moon for a long period of time and making all of our food there and not taking like prepackaged food like the ISS people, like what happens if you scramble an egg in 1/6 gravity? Does it not like float away?
So I mean,
Didn't you knock it all out of the pan?
probably not in 1/6 gravity. I know if you are on a dirt bike on like Phobos, one of Mars' moon, and you do like a sweet flip, you can like fly off into the void of space. But I think it's actually fairly difficult to do that on the moon. I know there was a little bit of concern when they got the lunar rover that like they could like somehow maybe do too big of a hop and smash, but I don't think.
Well, I'm not talking
Yeah,
like you're
I
gonna
know,
cook
you're
your
not
egg
talking
and
about, like,
launch it out of the
in space,
exosphere.
but just I don't know. I suspect that it will be more inclined to climb up the sides of the bowl, but I don't know if it's more likely to completely get flung everywhere. Like when you like put an electric mixer in a cake batter sometimes and it goes like everywhere. I don't know if that would happen just from hand mixing. I think that's still a little.
What if they have an electric mixer? What if our astronauts want cake?
So, I mean, I
Hand
would
mixers
say
are going to be just as good as electric mixers on the moon.
to
I
a
bet.
first order approximation, things would be moving about 6 times faster.
Yeah.
Like the amount of energy you put in is not being damped. So, I mean, if you crack an egg and that you ever see like a shell piece kind of just launch off, I mean, that's going to just be like whoop, gone across the room. So I think you're going to have like little mishaps, like almost as if
So
like you
you're
were
gonna
doing
need
it
a
like
lot
a
of
3-year-old,
rumors.
like, oh,
Yeah.
things are going to go everywhere because you're just, first off, you're not used to things bouncing the way they do.
Yeah.
You know, like I throw a ball to you, like its arc isn't, first it's going to go faster, right?
Yeah.
But it's two, its arc, its parabolic arc that we are so used to just, we're just ingrained into our brain of how a ball falls. That arc is going to be very different on the moon. So
Baseball on the moon's wicked wild.
yeah,
Yeah.
it's going to be like beaming you, it's
Well,
going to
that's-
almost like a straight line.
If you fill a dome up with air and you strap like wings to your arms so that you have a wingspan that's your height, you can fly on the moon, which is cool because it's 1/6 gravity.
I think a lot of
What?
Well, so if you strapped like fake wings to your arms right now, like a glider, and you like move them, you're not going anywhere. You're too heavy. If you do it on the moon, as long as you're in somewhere with an atmosphere.
Oh, with an atmosphere. Okay, yeah. I was
that's
very
the first thing I said.
Yeah,
You're
I
a
was
dome
very
filled with air.
I thought you meant you had like domes of air under your arm.
Okay, fair enough.
But yeah, I think that's more what the problem you're going to have is you're going to have like, with an egg, you hit the egg and, some shrapnel is going to come flying off.
Yeah.
Because normally it would just get stuck to like, that inner film, it would hold on to it, but otherwise it would launch. You're going to dump it, it's going to probably bounce, assuming there's not high cohesion, it's going to almost bounce off the pan, but come back down.
Like a raindrop.
Yeah,
Mhm.
you know, you're gonna get a lot of those things. And like I said, I think it's probably gonna be like a 3-year-old trying to make a cake.
Yeah.
You know, there's gonna be a mess, and things are gonna be also a lot further away from where you started the mess, which is already a problem we have on the ISS of mitigating things. You know, so I think if we take some kind of just imagine trying to take a shower on the ISS. In 2 seconds, you've already destroyed the entire thing. And the moon is going to be somewhere between the 2 seconds of ruining the entire space station and on Earth where there's no problem. I think that's kind of, I don't know, it's kind of hard to simulate 1/6 gravity.
Yes. So the closest I've gotten is again someone strapped me into a
Yeah.
belt that took like 5/6 of my weight off of me.
Let's move on. Well, there's like a lot more to go.
How many slides do you have?
He talked about so many things.
I know, that's why, but I want to get to the end is the fun part.
Oh.
We've been having fun with this.
No, but we're gonna have more fun in Okay. Vacuum, exosphere, parabola, composition, we don't know. Hardware has to work in a vacuum. Cool. Any questions? Nope. Okay. Moonquakes. Remember how we really wanted to talk about moonquakes and he didn't? Now we can. So there was a seismometers going on the moon by Apollo. There's 4 types of events. I found this cool graph that shows you the sizes of them. Yeah, not all of them. But deep moonquakes are associated with tidal forces. They're tiny little, woo,
So is that tidal forces just between the Earth and the moon?
yeah, tiny effect. Shallow moonquakes are bigger than deep moonquakes for some reason. Associated with unstable rims of ancient impact basins. So when it collapses, big.
So I'm assuming we don't have any information like, oh, we saw this collapse on a basin and it happened between these 2 orbits of this month.
Yeah, that was
And
like
maybe
that
that
was
was
a question that I had. Is how do you, because the majority of these were unclassified. So how do you didn't see it? I mean, I guess judging by the size of it, you could
Terrestrial analogs.
guess. Yeah.
I mean, you
But
could
you
tell
wouldn't know.
where, right?
Yeah.
But I don't know how you can say. I mean,
But
I
if
guess
all
they
you have
said
is this
something
little,
about it.
like it could be this, it could be that. How do I differentiate if I didn't actually see it happening? You know, I mean, I guess if you know it's in a crater and the crater now looks like it's collapsed, then you
Then
can
that's
probably
fantastic, right?
guess that it's a shallow moonquake.
Well, the problem is they don't have enough information to triangulate where it is in depth.
Yeah.
And the way they're analyzing this is on the basis of the wave patterns.
Right.
The fact that you get more SPZ than LPZ suggests that it's shallow, for instance.
Mhm.
Oh, so each one of these things is one impact or one event.
I thought they were
No,
separate.
well,
No,
So, like,
because
the 4 detectors that they have all get,
I
Oh,
thought
these,
data.
are four, these are 4
I thought these
different
were the 4
seismometers.
detectors,
Yeah,
right?
Okay,
yeah,
sorry.
these are 4, well, a seismometer will have is a 3-dimensional thing.
The triangle.
Yeah, and so you're getting X, Y, and Z, but you're also getting a detector that detects long period waveforms and then short period waveforms.
That
So
makes
is it
sense.
because the deep moonquake is showing more in the LP than SP that they're saying, oh, it's deeper?
That's
And it's
probably
also
where it's coming from.
Small in general compared to the other 2.
Oh, I've interpreted this wrong.
Me too.
Yeah. Impacts are big. So a question is, do we think that these events, moonquakes, are more or less common than these seismometers suggest? Because there's only 4 of them, right?
4 moonquakes,
No.
4 seismometers.
Yeah.
Yeah, I just don't know.
I mean,
Sounds like small numbers.
I would be
statistics.
surprised. I'd be surprised if the Apollo thought it was. I'd be surprised if he's overestimated rather than underestimated, because it's
Yeah.
higher chance of you missing one than you making one up.
Yeah. That makes sense.
But
Like also Apollo like flew to the moon with the same amount of computing power as our cell phones.
yeah, I don't know
Less.
how
Less.
Less than our cell phones.
My
So
sweet Razor cell phone from 8th grade was more powerful than.
I think one of those cards that you open up and play music to have more computing power than the Apollo.
Maybe not the cards.
That's what I heard.
Maybe not the cards.
like the
I
sound.
heard that like
musical
your
reading
TI-84 calculator has more
I heard
computing
that as
power.
well.
I mean, I
That'll
heard the TI-84 has 1,000 times more.
Yeah,
So
like it's ridiculous.
and a pocket calculator has like 10 times more.
Yeah.
It's ridiculous.
So I would agree that probably.
Remember those things you got at banks that you had to open up and you had to wait under the light to turn on? Those had 10 times as much. So
Okay. Talk about regolith for a very long time. Operating on lunar soil is not the same as in simulant. It's constantly being modified. When I say lunar soil, when I say regolith, that is the lunar soil, which is the tiny stuff, plus the boulders and rocks. So it's all regolith. But there's not a lot of boulders and rocks. But they do exist. The thing is, they're just slowly dissolved by micrometeorite impacts like this. This was underground. This part was above ground. That was underground. This is sharp. This is not sharp. But if you have a rock that's completely buried, it could survive. So the subsurface could have rocks under it, which could be a problem if you're trying to do something underground, dig anything. We talked about the maturity of the soil. So immature things are formed by recent impact. This kind of soil is coarser, it has less glass, fewer agglutinates, and less nanophase iron. And then when it gets exposed to micrometeorites, it makes it submature and then mature. And then this is where the just straight glass is. The majority of the moon is mature. You find the immature soil around the rims of the large young impact craters that are deep enough to excavate down to the coarse material or the bedrock and pull it out. And so it's easier to penetrate equipment into immature soil because it is not fluffier. Well, yeah, fluffier.
Yeah.
They said that like the astronauts' footprints were deeper on the crater rims.
yeah.
So a question, would it be better to send the first mission, or not the first, but you know what I'm trying to say, to mature or immature soil?
Mature soil because it'd be more compacted and easier for things
That's
to get
harder
around.
to like dig in.
If the immature soil is around new craters though, and it's the old craters that are suspected to have ice in them, if we're going after ice, wouldn't you want to go to places with mature soil?
Sure. I personally see the immature soil as like a bog or something that's your vehicles, assuming vehicles are going there first, they're gonna get trapped in. You want to.
Yeah.
Well, it's been there before, like the Apollo
You can
went
walk
there.
there.
That was with so a person
go
is not
into
the
a
first
bog
thing we're going to be
without
sending
dying.
though, right? No, not for people, but for machines.
Yeah.
Well, but we'll just send a doggo and it'll walk.
I just picture it tumbling and slowly up and down the crater. And it's like doing the wabble.
Oh, jeez.
But yeah, I mean that's just how I think of it. I mean, we saw how all those things had trouble with it, and if anything, because this is not 1/6 gravity, those fives on that scale are still going to have trouble, if not get completely stuck in that super immature soil.
Hmm.
You know, I think it would make more sense to try and go somewhere where at least your vehicle can move.
Yeah.
Well, I'm not sure that you're mapping maturity to fine particle sizes here. So immature soil is actually going to be coarser. Yeah, all you're talking about here is the process of micrometeorites turning it into glassy aggregates in maturity.
So you don't think it has to do with compaction?
No, not at all. I think that the immature soil is actually probably more compact than the mature soil right on the top because it hasn't been gardened by micrometeorites.
Well, then why is it easier to stick stuff into it?
Into what?
The immature. No. Yeah. Nope.
Yeah,
I get it now.
okay.
I heard what I said.
So it's easier to penetrate equipment into immature soil,
That's what they said.
which it might very well be.
But that's less compact or more compact?
Yeah, well, if it's less compact, then it would be easier to penetrate. But
So I
all
feel
I'm
like
saying is that a recent impact is going to produce stuff that's coarser. How the penetration works is another story.
I'm just thinking about it because almost everything they showed was either wheel or track or a frisbee.
Yeah. I like
And
chicken
if-
crispy.
I'm just thinking that those things are going to get trapped in that fluffy, that less compact environment. So I'd want to stay away
Well,
from that.
is the environment actually less compact in permanently shadowed regions?
I don't know.
We don't know. Shadow.
Sounds like something Boston Dynamics song I would hear on.
Stink spot.
That image of the Boston Dynamic dog just slowly falling at 1/6 gravity down the crater stuck in my
Well, it
head.
would be interesting to see if somebody actually runs a quadruped into this.
I'm surprised
tournament
it hasn't.
sometime.
I know
think it's
difficult
only a
with
matter of
balance,
time
but
before someone tries it at this point.
Yeah.
I just want to see it immediately.
Wheels are so last century.
Yeah.
Yeah. I'm just, I don't want to run out of time, so I'm gonna skip.
You have 20 minutes.
Skip a lot. I know, and there's a lot more.
Insane.
The regolith is very cohesive. It acts like wet soil, even though it's dry, kind of like moon sand. Did you ever play with that as a kid?
I've got that in my house.
There's moon
As soon
sand.
as you said it,
Yeah.
It's a,
it
yeah, it's a
acts
little,
like-
Squeeze it. Like it's,
toy.
I thought it was just called moon sand because that's like a cool name, but no, it's because it acts like this.
It's
It
sand
actually
with
acts like
mineral oil in it. And
It's really cool. You should buy some.
And that acts like lunar regolith.
It's sticky, but it's dry.
sculptable, but it's
Oh, I
it's not
see,
wet.
okay.
It's
All right.
moon sand.
So it has, it mimics the electrostatics.
Kind of.
yeah.
yeah.
As best as
All
a toy could do.
Yeah.
But the reason for this cohesion is because the particles are very fine, there's no humidity, which enhances the van der Waals force, and the shapes aren't round, so they interlock with each other. This means that we can have pretty big stable slopes, but they can still collapse. This is a map of slope. This is not sloped, and this is 30 degrees slope. And so around craters, obviously, it's the most slopey. But it gets pretty high, or I have a point. It gets pretty high in some places, which is really cool because you can't do that really well on Earth, but it also could collapse. So how is this problematic? I just
If you going up the side with your little rover and then it collapses and then, yeah, that's kind of bad.
It gives you a false sense of security. You go, oh, I can go up that.
Yeah.
Especially with 1/6 gravity, I'm gonna be light as a feather.
Have y'all ever seen a video of like there's a slope, like there's a bunch of videos out here like this, but like slope in Sahara and someone like pokes it and it all just
It all
like
falls
starts
in.
slides down.
Yeah.
Yeah.
It's like an avalanche.
It's like well no, it's not like an avalanche, it's like it
Sand.
all turns
Rock
to like
slide, kind
liquid
of.
almost.
Yeah.
Yeah. It's a fluid as soon as they touch it.
Yeah, it's not going as a sheet. It's,
Yeah.
This would also be a problem if you have, like a bulldozer and you're dumping.
Hmm.
You have to have a really high tilt angle or it's
Yeah.
not gonna come out.
Yeah, that's a good point.
Keep going. Oh my god, there's more. Lunar soil is magnetic, so we can use magnets. We talked about that a little bit. It doesn't flow well because there's high friction from the sharp particles. There's the high cohesion and low gravity. I found this. These people did an experiment where they had 3 different widths of this funnel. They had 5 different inclination angles here. They used 2 different lunar simulants, different masses, different pressures, and different gravities, and I don't know what funnel geometry. Oh, yeah, so it's symmetric or anti-symmetric. Anyways, they did a bunch of experiments, put it on the Vomit Comet, and what they found to test flowability, and what they found is all of these things. Flow rate is proportional to gravity. Flow rate is proportional to outlet size. If you have a constant flow rate, the outlet size is inversely proportional to the gravity. Arching and clogging occurs randomly, which we kind of talked about. High inclinations tend to lead to higher flow rates. That makes sense. There's good repeatability for some of their configurations, and asymmetrical is good. So I just thought that was really cool.
That's cool.
This is this person.
what was the asymmetrical configuration? Is that the?
So like this would be symmetric, and then I guess if you had like this one more inclined than that one.
Okay.
So that was cool. And then we also talked about how to keep the stuff from jamming, and we talked about pneumatics would work, but then the Trago charged the pipes, and then they got shocked really bad, which I think is really cool. Amy said that we could harness that energy and use it for our own good, which I
Okay.
agree. Yeah, the shock.
So we found that the flow rate increases with increased slope, right?
Which makes sense, right?
Yeah.
Because
So then why can't we have just something that like it's kind of just like a square box, and then we just remove the bottom panel and have it just all fall out, and then
yeah, I think
is
it
that
gets,
is that one of them? Okay.
I think it gets clogged.
Is that what? Oh, okay.
I think that's what Phil said.
I'm thinking
I
of
don't
like,
remember.
yeah, you're trying to like dump more and more in, and yeah.
Because it's gonna like compact, and then that's gonna make the cohesion more and the
Just
so
do
you
the
want it to
opposite.
be
Flip
this
it
way
upside down.
Mhm.
so that it's less.
Alpha powder.
I'm not explaining this.
I mean,
as
like
well as
even
I
on Earth, it would not lunar regolith. You can very easily clog up like the straight spout part of a funnel.
Sure.
Yeah, screws. Amy said that. Anything else? We're gonna skip that for the sake of time. Trafficability was drivability. We talked about this for a really long time, so I'm kind of gonna fly through it. But the lunar rover was a large vehicle with large wheels and had no trouble driving on the moon. These are the tracks. This
The
is,
wheels are made out of piano wire.
they're really
Yeah.
fascinating. When we test in lunar simulants, we see problems with small wheels. We talked a lot about this robotic mining competition where they saw a bunch of rovers with a bunch of designs, and they used this soil that was the crushed basalt that one astronaut said was like lunar soil. The only thing with this competition is that they can't simulate low gravity or vacuum environment, but it's still cool to see these kind of things. And I thought this was really cool when we talked about that, how they compacted it, and it was like toe holds to push themselves.
Did he mention which NASA center this takes place at again?
Honors.
Got it.
Kennedy.
Okay.
Do you know where in Arizona the not moon dust comes from?
Yeah, he said it, and I forgot it.
The San Francisco volcanic field.
Hmm.
Near Flagstaff.
So I'm not gonna show any of the pictures because we looked at a bunch of pictures, and I feel like this is the part that he spent the most time on, so I'm gonna spend the least time on it. But I just thought this was cool. Seeing all of it. There's a bunch of different designs that they could do, and the majority of people use four wheels. Don't have any type of suspension system. They use skid steering methods, which doesn't. I don't know about, cars and stuff, but that doesn't seem good. And the mining methods was majority bucket ladder type thing. So I guess a question I did have was which designs seemed like they would and wouldn't work and why? I thought that four wheels seemed like a good idea, but then he showed all those pictures of the ones getting stuck. So maybe there's a better. He definitely did say that the.
Boston Dynamics doggo.
He definitely did say that the tracks was bad.
Yeah.
I was interested that no one tried to cover the
sides of
treads.
it.
Yeah.
Yeah,
I thought about asking that, and I was like, nah, these are engineers. They
I also had that same question.
surely know what they're
Kind of make the BB-8 robot. Just a big seat roll it.
Yeah,
Maybe,
one-
like something to cover the sides.
Yeah, so the treads wheels were exposed, and I was like, why haven't they
I was thinking the same
put in
thing.
a plate so the dust
I
can't
guess
get in
the
the
stuff
wheels?
would still get in.
Yeah, fine scale stuff. Yeah, and then it couldn't ever get out once
Yeah.
it was in.
Yeah.
But you're also only there for 10 minutes. So.
Well, okay. This is about getting stuck. I'm gonna ignore it. This is about his 7 parameters, and there is this nice correlation, which it is a correlation.
I still want to know how he made that equation
They're
of
big
all the different
numbers.
features. I really want
The
to.
combination metric is pretty large in arbitrary units, so I'm assuming there's a multiplication in there between each.
Yeah.
Assuming.
You know what I mean? There's 7 parameters. 5 to the 7th is 5, 25, 125,
I guess you would.
A large
probably
number.
about
A large
probably about those numbers.
There's
So it's probably
definitely-
just 1 through 5 for each one multiplied by each
Yeah.
other.
Are there any other
The seven
parameters you
is
think
much
might
smaller than that.
need to be included in this?
Torque.
I'm gonna keep harping on this. I think that legged robots are the way to go. And
Well, then-
obviously they will not fit into wheel diameter wheel width.
Diesel or
Would a mass be important, like the mass of the vehicle?
Potentially.
Yeah.
The heavier it is, the
You can-
it will less likely to tip and
Yeah.
more likely to stay,
but also more likely to sink.
more likely to sink.
But it could also, that could be a good thing. It sinks. If the wheel's
It
bigger,
could
then it can
compact
sink.
more if
Yeah.
you kind of design it that way to like kind of incorporate the mass to that advantage.
Well, that's like the toe hold one that we're all, I think, very impressed by.
Yeah,
I don't know if that will work in 1/6 gravity as well.
yeah, because it's not as heavy.
Thinking like scoop wheels that have like a thing that's actually, so it kind of pushes itself backwards. Almost like a water, like a, what are the,
Yeah.
Like a old timey Mississippi river.
those
what are those
things.
called?
A river.
Riverboat, yeah.
Yeah.
But yeah, I mean, I thought that would be an interesting
Yeah.
mechanism, with the long spokes coming out, but
That is kind of cool.
Dust. It's dusty. It's bad. Ice. There is ice. Could be bad. I just want to get to the end, which is why I'm skipping through these. If you want to stop me, then please stop me. Plume ejecta.
I really like this stuff.
Okay.
But
we can.
I
talk
feel
about
like we
this.
could be here for another hour, so.
This
Oh.
slide flickers and I hate it.
Well, then that's a reason. Okay, so I thought it would be really fun if we looked at, these are the ones that Kevin showed us. I thought it'd be cool if we looked at like ideas for moon bases / rover digging things, and then based on what we know about operating on the moon, could like
Could we
critique
select?
them.
Yeah.
Better word for critique, but critique them. So,
Compare and contrast them.
yes, okay. So this guy, oh, these are bad pictures now. Well, okay. So there's these like pole things, and then up here above the crater is like cylindrical solar panels. And then it looks like they have stuff under here. There's like a mountain here to hide their landing pad behind a mountain. And then there's like little rovers moving around. So is this a good idea?
So I'm still stuck on, because you obviously want to be able to see.
Yeah.
Jack Schmidt said that when he was in darkness, he could still see relatively well, but he's not sitting in a massive PSR that could be literally
Right.
tens of miles, hundreds,
Right.
100 miles across.
Right.
Where the center of that is going to be a lot darker than the center of behind a large boulder where I assume he might have been in. But
People get seasonal depression from moving.
Oh, I'm
these
sure.
sites.
you'd hope that astronauts would be tested for that. But yeah, but that would be a problem. But I'm just wondering if you're illuminating that area, right? You are immediately losing volatiles.
Yeah.
Like anywhere that you can see in any of those images,
Mhm.
the volatiles are already gone.
This
At
one looks
least
like,
in the upper.
this one looks like it's drawn to where it's one of those ones that's only partially permanently shadowed, right? Because that looks a little lit. I guess it just depends on which one you're going to.
Mhm.
But then, like what you're saying, like these
I like that.
solar
I think
catcher
that's
things,
an
they're high up,
interesting
yeah.
design.
So they're not gonna.
But would that be more advantageous than simply putting it on top of the crater rim? Then you don't need to build these high structures, which could be very
Right.
easily destroyed by a.
Anything.
I
Doesn't
mean,
that
I'm
restrict you
sorry.
to only living near the edge of the crater? Whereas if you want to live in the middle, at that point you need like a really long extinction cord.
Well, I mean, imagine
Yeah,
if this crater is say 20 miles across, right? Then how tall do those things have to be? Because the crater rim of a 20-mile across
Yeah.
is
Yeah,
already
that's a
going to
good
be massive. So I feel like just laying a cable
Yeah.
or something would be. I'm just wondering this scale, because on that scale, that image is only how
I
big.
mean, it is just
If that's
like a.
Would you want to pick something the size of Meteor Crater to be your base of operations?
Meteor
It's not
Crater's
that
only
much.
a mile, isn't
I
it?
mean, that's about how big these images look, right?
If I was gonna
This
pick
looks
like
smaller
a
than
primary
Meteor Crater,
crater, I
It's
would
smaller.
pick a small crater to mine first, because you have to assume that you're gonna lose the majority of the volatiles in the first thing that you mine.
Because you don't want to ruin the. That's like the first pancake.
Yeah, exactly. Yes.
So I mean, so based off that, I want to go to a place that I know have a lot of resources that I could waste, rather than imagine if you come to a place like this and you're wasting resources if there's only so much.
Well, it's the difference. Okay, so NASA is a big fan of funding proof of concept ideas. So I would imagine that the first lunar excavation site will be a proof of concept excavation site.
But at the same time, if you don't immediately produce results, you're not going to get funded anymore.
Right.
I mean, you're gonna get results.
Might not be good
It
results.
depends.
Yeah.
You'll
Like
get
if you go to a
results.
really small one, yeah, like you were saying, you're gonna lose everything really quickly, so you're not gonna have a lot of tangible results.
I would personally pick one that is closest to other interesting sites.
So you can,
Kind
Yeah.
of zigzag through,
So
yeah.
that you can get
that makes sense.
the highest science payload out of your proof of concept and be like, wow, look at all these things we did.
I just feel like going from one crater to another is relatively infeasible for the first 20, even 30 years of exploration. I mean,
Why?
so you need some kind of launch pad then, because you're not going to walk up the side of the rim.
Sure.
Well, that's what we were talking about that one time where we had like the rovers. Like you could just send up. Depends on how close you are with like
I mean,
the crater that you're in to the other craters.
These little rovers have trouble just going over flat.
Yeah.
True, but I mean-
the rover that the astronauts used was able to go up, I think, a 60 degree.
Yeah.
Was that what it was? And that was a lot heavier, a
Yeah.
lot more massive, and could really grip onto things. So unless you have something of that scale, I mean, I don't know.
Well, you can
I've never
also
stood on the
always
edge of a
like
crater, but
pave it. You can pave something fairly easily.
What if they did like a crane
here
thing
you can.
where you just attach
I don't
the
think there's
rover
that much.
and
Well-
then you'd rotate the crane over
But
the
didn't we
PSR and
also-
slowly lower it?
We also
Yeah,
learned
But
that
the rim is a
the-
kilometer high, though. That's
the
kind
torque.
of
Yeah,
the torque from the
stays
crane
same.
Yeah,
can
the
cause
torque
it
from
to
the crane.
topple really easily.
But my
Just
worry is the
very,
scale.
Very slowly. It doesn't have to be like.
That's a good thought. Yeah.
Just like
If you have it what?
Just is like bring it over.
6
and-
squares
That's true.
slower.
We'll be able to
you're
beat
good.
them.
really slow.
But what about the
Do it.
slingshot? Just like sling the. We're talking about that.
Just
I was
ricochet
thinking like a
everything,
cable
yeah.
car, like a ski lift type.
Yeah, that would be good.
How
I-
frowned upon is nuclear? Like,
Depends who you're
I really think that
talking to.
nuclear is really good.
I think
I
it's
feel like the
awesome.
I get that there are
Soviets
hazards
could do
for
it.
launching it.
The Chinese
Yeah,
can do it.
But what if you go get it on the
Americans
moon?
not so much.
You don't.
No, but even if you are launching it, like, what's the maximum amount? They let you put it on Mars rovers. Like, how much?
Yeah, there's a
How
little
much
bit of
could you spend?
plutonium on the
Only
Mars
takes one time
rovers, but it's
for
like
things to
less
go
than
terribly wrong.
I think Curiosity has less than 2 pounds of plutonium.
No, it's
I
more
thought it
like
had, like,
20
11.
kilos.
Oh well.
You could also send one of those things. I mean, the main worry with the reactor is that it breaks up in your atmosphere and disperses the material, right? That's the
Yeah.
worry. You know, so if you bring it up in parts and you say, you know, here's this part of the machine and that's the other part of the machine, and
Well, but the whole point
Well,
is to reduce the
we're doing
launch
mining,
costs.
so I'm assuming there's lots of launches at this point.
Yeah.
My assumption is that there are launches happening all the time in order to
That's
do
true.
this.
Well, yeah. So
Well-
you have other payloads that you're trying to get up, and so instead of sending like one payload that's only nuclear material, you split it among the
Yeah.
6 total launches that you do.
Yeah.
That
Do
makes
you
sense.
still get waste from it? Like,
Yeah.
You don't
Yeah, you
know
still
what to
get-
do with.
But if
That's
so,
Eat it
so
into the
Send
sun.
it into space.
Yeah.
Yeet it out there.
if Curiosity's
Right.
RTG is 4.8 kilograms, and
Say that again.
Curiosity's RTG is 4.8 kilograms of plutonium.
Okay, I was
And-
wrong.
I mean,
Didn't-
that's not an max,
Didn't
though.
one of the
It's just-
people in Journal Club say that an RTG is like millions of dollars? Like,
Yes, it's very expensive.
if that powers one little rover, like, to run your whole base on nuclear would be stupidly
Well,
expensive, wouldn't it?
They're not talking about using RTGs, they're talking about using a uranium fission
Okay.
reactor.
Really dumb question. What
Which-
is that acronym that you guys are saying?
RTG,
Yeah.
little
Radioisotopic
box of plutonium that keeps you warm.
thermal.
Thermoelectric generator. Yeah.
Got it. Thank you.
So it's just heating it up, or is it running it?
Well, what happens is you make electricity from the heat that the plutonium produces.
But yeah, so my whole thing with these is, me personally, if I don't know how efficient my machine is going to be, because it's hard to test on Earth how efficient something's going to be,
Yeah.
is I would want to go to the biggest crater that I think has supply. So like the most volume of whatever I'm trying to mine, I think is there at a
No.
reasonable depth.
Well, why not?
You're
Why
gonna
not?
ruin it.
No, why not just go to this part?
You'll ruin more of
Go
the
to the lip
smaller
part.
one first.
You're gonna okay, but alright, so like let's say the smaller one is 1/10 the size and you mess up and you somehow release all the volatiles. That's upsetting.
But I mean,
Things
one of
like
one of these
that,
craters
no.
is the size of Connecticut. You know, like you're only gonna be messing with something the size of the football
I would
stadium.
go to a partially lit one and go to the lit part and
Yeah, I like
then
that idea.
move it.
That's a reasonable thing.
Yeah.
I think if you're trying to go to a PSR though, and you're going to a reasonably sized PSR, trying to build a structure,
The tallness thing?
to go
Yeah.
over the edge of a crater
What about
And
is
you're
not
gonna-
good.
what about this little number?
That's slightly more.
Is that
feasible,
the
but-
mirrors?
These are the mirrors.
Yeah.
Isn't that just gonna cook off all of your volatiles?
That's
No,
my
because
worry.
look, they're directed directly at this. It looks like the charging.
But isn't there
I mean, the fact that we
Some,
can
like,
see those beams
the-
tells
Yeah,
you
oh,
that
sure.
yeah, like the
Refresh,
dispersion or
right?
what
I'm
what's the
sure,
word I'm
yeah.
looking for? Yeah.
if there was no
Like it's not
diffraction,
going to be
it would
completely
still look
collimated.
pitch black.
I also thought it was funny how they covered the floor.
Let's just
well,
get rid of
that's
all the
strange.
volatiles
You're
at
gonna
once.
save the floor.
Put a tarp down, maybe.
Very cold.
For the sections you don't want it to get any light.
Let's just constantly pour liquid nitrogen onto the surface.
Just
Keep
freeze.
it cold.
would be
Just keep it
like
I have
Helium.
more of these, but I don't know when this class ends.
Well, I think we need to wrap it up.
We can stop here then.
Sorry, Nisi, this
That's
was
okay.
fun.
There was like
I
there was like
enjoyed the
8
talk.
more of these things.
So- What's going to happen? Let's go back to that other slide,
Which one?
the one with the power towers and the.
This one.
Yeah. So one of the things I like about Colorado system here is you're shining sunlight down in order to pick it up in the crater. What happens if not 100% of your sunlight is at your detector, your collector or whatever?
You've
Yeah.
leaked energy everywhere.
That's what he was saying.
vaporizes the
Yeah,
material around it.
Just
So how good is solar array at the poles of the moon? Is that what's the
Yeah,
watts
that's
per
a good
inch
point. That's
right
the
down
weakest
there?
light.
And that's why I think these probably rotate, you know?
Yeah.
But I mean, yeah, I thought this was a really cool idea when we first saw it, and then after this talk, I was like, this is why it's wrong, and this is why it's wrong, and this
Well,
is
if
why
you,
it's
if you can make it into a laser or something, then
Yeah.
then you can
focus
direct it
on
down to a
it.
very fine point and
Yeah, I don't
Or
think
it's
you need
fine.
mirrors. You
So
could just
I was gonna say the
collect
mirrors. I feel
solar
would just
panels.
I think the solar
Disperse
panel,
a
if
lot
you
of
just
it.
put the solar panels up where the mirrors are,
and then do like a
And then
cable
pumped
down
it.
like we.
Or even a
We should
laser.
just
You
do
could
this, guys.
directly, concentrate it really, really strongly.
you have that precision, then
And beam
then
it.
those things are great. You could also just physically, I don't know, make a nuclear powered laser.
Oh,
It's probably easier just to
Well,
use the nuclear energy.
you know, there's this sort of nuclear energy is about, I don't know, 15% efficient. So you get a lot of thermal
Yeah.
for this.
Okay, Brit, I'm sorry to, you have the meeting till 12, right?
Yes.
Okay, yeah, because we have at 12 here some event, thank you.
Okay, what event do you have at 12?
Excuse me,
What event?
it's, you have a visitor today in the department,
Okay,
and the Women's Society, they invite her for
All
lunch
right.
here. at 12.
okay,
Thank you.
sure. Okay,